Hello F-sharp, and welcome back to our Intro to the F-sharp Language series. Today what we're going to talk about is something that is actually not unique to F-sharp, and it is the generic collections in the .NET runtime. One of the fantastic features of the F-sharp language is that it is a .NET language. Now, that's not entirely true because we also have the Fable compiler. So F-sharp is also a JavaScript language. It's also a Python language now, and it's also a Rust language. So F-sharp can actually be compiled to many different backends. Now, the .NET CLR is the most common one right now, and one of the features of the F-sharp language is it can use any of the facilities in the .NET CLR. One of those is the generic collections. And it's a set of collections that I use extensively. If you're coming from C#, you've already worked with these quite a bit. And what I want to show you is how do we work with them in F# and how they are different from the F# collections and some idiosyncrasies around type inference. Now, typically what you would want to do is go ahead and open system.collections.generic. And you now have access to all of the collections that are inside of there. And some of the most common ones are the hash set. So if I want to create an instance of the hash set, I can go ahead and do that. And why is this complaining? So one of the first things that I want to point out, if you are coming from C#, you're probably used to having to do this. And let's just say this is a hash set of type integer. This is not necessary in the F# language. What we can do because of type inference is we can remove that type information and we don't need the new. But right now the compiler is complaining because it's saying, okay, you are wanting to create an instance of the hash set, but there's not enough information for me to be able to figure out what kind of hash set you're wanting me to define. So right now it's saying, hey, I'm creating a generic hash set and the generic parameter is obj, just a .NET object. Now, this will go away the moment we actually start to use it. So we say, hey, we're going to add 1 to that hash set. And what has happened is now the type inference has enough information to be able to figure out, oh, I know what kind of hash set this is. This is a hash set, and the generic parameter is an integer. And that means that we don't have to put in these generic parameters if we don't want to, because of F#'s type inference, it can figure this out almost every time. There are some rare cases where it gets really confused, and I will show you some of those. But again, for the most part, I rarely have to provide the generic parameters for these collections when I'm working with them. Now, something to be aware of, and this is one of the things that you will want to be thinking about when you're working with F#. If you are working with F# collections, list, map, set, those are all immutable by default. And much is made of the fact that F# has immutable defaults in the language, and that is true. But F# is a very pragmatic language. It allows mutation. And when we work with the generic collections from .NET, they are mutable collections. And so when we work with them, they are still mutable collections. The F# language is not magically making them immutable. They are mutable. And so when I do this, I can go ahead and run this. And I'm going to say, okay, well, what is in that hash set? Oh, come on. I say it is giving me, hey, there's a value of 1 in here. And then if I say, hash set add 2, and then I say, okay, run that again. What we see is that, okay, we have values of 1 and 2 in here. So when we add that value of 2 to the hash set, it goes ahead and adds it to that existing hash set. It doesn't create a new instance of a hash set and then add the value of 2 to it. So hash set is a mutable collection. And that's something if you started with F# as your very first language, and you're just used to things being immutable all the time, and then you start using collections from other languages, you may not expect this. Now, I don't know if I would say I'm fortunate or unfortunate, but F# was my first industrial strength programming language. I think that's how I'm going to say it. And so it did take me a little bit by surprise when I had been used to working in the F# language and having immutability by default. And then I start using the generic collections from the .NET runtime, and there's mutation there. It was like, oh, there's no warning now that, hey, I'm mutating things under the covers. So that's something to be aware of that is happening. Another thing you will notice is that when we call add, it is returning a bool, but we're not using it here. Right now I'm in a scripting environment, so it doesn't really care that I'm just throwing away the values, but I could say, hey, let x equal to, and x would be the result of that addition. Now the add method returns a bool whether there's actually a new value in here or not. Now let's go ahead and use this in a function. So let my function, and this is going to take a hash set, and I'm going to say it's just an unknown parameter, and I'm going to say h dot, I'm going to try to do some things here, add 1, and then print function, hello world, and then I'm just going to return 1 here. I mean, this is nonsense, but my point is I didn't want this to be the last line in this function. Now what you're seeing is that we're getting this little squiggle here saying, hey, something's going on. And now what's happening is the compiler is saying, hey, this method returns a value and you're not doing anything with it. Right now, I'm implicitly ignoring it, but F# would really rather you explicitly be doing something with this. Now, when you're used to just working with the F# collections, this doesn't come up as much just because the shape of those APIs doesn't cause this type of thing to happen very much. But again, when you are working with the generic collections in the .NET runtime, they have these interfaces which may or may not return values. And because C# is more of a imperative style of language, I know it's object-oriented, but it is perfectly fine to just call methods and return a value, but then do nothing with that value. In F#, everything's an expression. Everything is returning something. That something it's returning might be unit, which is the idea of, hey, I did a thing, but there's no value for you, but I still returned the fact that I did something, that something happened. I'm not going to, there's no type associated with it. It's just the unit type. It's kind of like void, but it's not technically the same. So when you work with the generic functions, this type of thing starts to happen all the time. It's like, okay, well, add returns a bool, but I don't need that. I don't care about that. So what do I do? Well, there's two different approaches here. One, you have the ignore function. And what the ignore function does, I'm going to go ahead and put this down below. What the ignore function does is it will take any value and basically consume that and return unit. Where it's saying like, yes, I am acknowledging the fact that I got a value back from this expression and I'm not doing anything with it. And the F# compiler would rather you be explicit about the fact like, yes, I acknowledge the fact that I am not using the value that is returned from this method, and that is okay. Because again, the F# language in general is designed around having safe and reasonable defaults, and it's defaulting toward safety, not just assuming things for you. It wants you to be explicit about what you're doing so that it is actually helping you in the long run. So you have these two different approaches. I've showed you one. You can pipe that into an ignore, which is a function that will take any type and just return unit and say like, okay, yep, I don't care. You could also do this. where you're saying, yes, I am returning a value and I am going to use this underscore to indicate this is a throwaway value for me. Underscores are used to say this is either generic in terms of what's the better way to say it? It's essentially a wildcard and then an ignore, where when it's used as a generic parameter, it's saying like, you know what, the type doesn't really matter here, but I need to fill in something, so I'm just going to use an underscore. I could put it in type of T, but I'm not using that type, that generic parameter anywhere else. And so instead of putting in type T, I'm just using the underscore to say like, you know what, it doesn't really matter for the sake of this. And again, type inference will figure it out for you. And what's actually happening here is type inference. Oh, it's not showing it here. Oh, if I hover over the H. Yes. The type inference has figured out, yes, I know that you didn't put any definition on what this generic type parameter is, but I am able to infer by context this hash set that you're passing in must be an int hash set because you're adding a value to it. And therefore the type inference is flowing up and saying, hey, based on the usage, this H hash set must be an integer hash set. Okay. So again, that's why we're using this underscore as saying, yes, I acknowledge that this is returning a value and you want me to bind that value to something. But when I use the underscore, it's essentially saying like, I don't care in this case. Like, yes, I know I'm getting the value back, but I'm not going to use it. And so this is the other approach that you could use to saying, you know what, I'm going to ultimately ignore this value. I don't worry about it. Which one you use, it's really up to you. It doesn't really matter. And what I mean by that, I've not had an experience where it has really mattered significantly. I end up typically doing something like this, or you can add a no warn at the top of your file saying like, yes, I know don't warn me about the fact that I am doing this. And so I could go ahead and put this no warn up here, no warn. Let's see, 20. Yep. So I could put this no warn up here to say like, hey, don't warn me about this compiler message. And the compiler message around you are not using a value that is being returned is the compiler warning 20. I can go ahead and comment this out and hover over and show you that I'm not making things up. Scroll down here. This is compiler message 20. And so it's like, you know what? Really don't care. And let's say you're using this type of API all over the place inside of this file, you could go ahead and put a no warn of 20 here at the top. I strongly suggest against doing this because it applies to everything. I want you to be aware that it is available, but typically, almost all the time, I end up doing this because it's not that much additional work. I have thought about this line of code, and yes, I do want to throw this value away, and I am acknowledging that, versus just wholesale, like, yeah, you know what, don't warn me about it anywhere. I would do this if I was writing a library where I was having to work with a collection that did this type of thing extensively, and I had to do this all over the place. But that would be the only situation. In just general business logic code, I would recommend against using that no warn. Okay, so we saw an example of using a collection from the system collections generic namespace. We've seen how it's able to use type inference a lot of the times. We've seen how we've had to throw away result values at times. Now let me show you a situation where you might actually really want to be explicit about the types that your collection is using. And I typically run into this with dictionaries. So I'm going to go ahead and define some types here. I'm going to use my classics. Got my chicken, just name string, and I have type turkey. Again, name string. So these two look very similar. I mean, they are the same. They are different types, but the fields in them are the same. And let's say I have let my, I'm going to say this is just a dictionary. I'm just making it completely generic. And it does not have enough information at this time to be able to tell me what kind of dictionary this is. And so, okay, well, let C equal name Clucky. No, I'm going to say Turk. Gobble. Make it safe. So, and then I'm going to say, hey, I'm going to say like, you know what? I'm going to put this value here. Now, type inference is doing some work for us here, and it's inferred a lot of things for us, and it's actually inferred some things incorrectly. And what do I mean by that? I'm coming up with this kind of silly hypothetical situation, but it's something that you'll run into if you really rely on type inference too much. And again, this might be where I diverge a little bit from the rest of the F# community. Like, you know, do what is best for you in your experience. But what I have found is when you lean on the type inference too much, you can start getting wacky bugs and compiler messages saying like, hey, these types aren't aligned or something's going on. And what's happening is that when you wrote the code initially, the type inference was doing exactly what you expected it to do. And then you've gone back and you've refactored something. And that refactoring has caused type inference to massively re-understand huge portions of code. And so now you'll get bugs really far away. The problem, and what I mean by really far away is that it's inferring something here, and that implication is trickling way down the code base, and it's not actually a problem until much farther down, and that's where the compiler says like, hey, these types are misaligned. But the mistake was made far away because the type inference is flowing really far until you get there. Maybe sometime in the future I'll come up with an example of this. But this is kind of like a silly, very small example, but you can imagine this kind of going across files or something. And what's going on right now is I really intended for this to be my turkey flock. So I'm changing the name. And so that's what I really intended for this to be. And well, chicken flock. Okay. I really intended for this to be a chicken flock. Oh, this is my dictionary. Sorry. Yes. So chicken flock. That's what I really intended to be in this dictionary. But what's happening is that the type inference is saying like, hey, the last time I saw a record with a field of just name is this turkey. So I'm inferring this to be a turkey. And then I'm using it. And then let's say farther down, let my other chicken, and let's say I just happen to be a little bit more explicit this time. Okay, well, chicken dot name equals Clucky. And now I'm going to say, hey, chicken flock, and I put another value in here. I'm going to put this at 2 and say my other chicken. And now you're getting some type collisions where it's saying like, okay, well, this is the type chicken, but I'm expecting this to be turkey. And I know in this example, this code is all right next to each other. So it's relatively easy to see like what is going on. But imagine this, like I said, imagine this being really spread out. And because of like, and this is where I talk about like relying too much on type inference. You've been coding. All the type inference is doing exactly what you want. Types are just flowing. Everything is great. And then there's one thing that you do, and now the type inference is inferring something slightly different. And that is cascading through all your code. So imagine there being a ton of code between these locations. And you're like, why is this turkey when it's supposed to be chicken? And it's because you didn't provide types here. Now, like I said, you don't have to do this. And most of the time I don't have to, but sometimes it is advantageous to actually put this type inference this type information here when you create an instance of these generic collections. So you don't always need to, but sometimes it's helpful. And especially when you have lots of types flowing around, it might be to your advantage to be a little bit more explicit about what you're intending to do. And now the bug is coming up sooner, like, oh, well, you're trying to add this thing, but I'm inferring it to be a type turkey. And like, oh, no, that's not what I meant. Oh, I realize now that I defined these two different records. They're really close, but they're different order. And so by doing this, by putting the generic types here, you will get an error the very first time you make a mistake with it. It's like, hey, the types are misaligned right here. And imagine like lots of code in between here. So imagine there's a ton of code in between the two different places. By putting this information here, I'm getting a compiler error the very first time I use it instead of really far away when it may not make sense to me. Like, hey, why is this having a mistake here? This doesn't make sense. So I find when the type inference is going wonky on me, sometimes it's a good idea to fill this in. Like I said, most of the time I don't need to. It's just a tool to have in your tool belt for debugging type inference. And that is a very real thing early on. And this is part of why I suggest being explicit about your type parameters, your argument types, and your return types. Not everyone else agrees with that, but I have found it narrows down my debugging time because I'm not confused about what the type inference is trying to do. I don't spend much time debugging type inference because I'm a little bit more explicit about it. But do what works for you. When working with the generic collections, this may or may not be a useful tool for you to have. So this was just a really quick intro about how to start using the system collections.generic in your F# code. Be aware that these are mutable. F# doesn't magically protect you from these mutable collections. And sometimes you may have to provide generic type information, sometimes not, and sometimes you might have to throw away values because these APIs weren't really designed with F# in mind. But F# doesn't make it difficult to work with them. So that's all I have for you today. Thank you very much for spending some time with me. It's been really wonderful hanging out. I hope you have a great day. Bye-bye.